Hello everyone, this is Ranjib from Uber. I work in the production engineering group and I'm here to talk about culturing resiliency with data, a taxonomy of incident. This talk is focused around our learnings, around analyzing and learning from around few thousand incidents over the last few years and how we have used those data to improve our overall tech stack reliability and with an emphasis on the cultural aspect of it. Before we begin with, let me give you some background around how this talk is panned out. It is overall divided into three sections. We'll start with some basic background and context, where we'll talk about what we call as incident, how it is managed and processed at Uber, and then different life cycle process around the individual incidents, the personas, and what kind of tools we use to catalog those. And finally, the main body of the talk, which is the categorization of this incident, their basic properties, and the rationale for this categorization. And then we'll jump into the last part, which is the couple of key learnings from all of those incident analysis. So with that said, let's me start with a few background details around what constitutes an incident at Uber. An incident at Uber is a partial or complete deterioration of our service. Think of a typical Uber rider or driver or a eater or a restaurant when they're not able to use our product at all, or if they're able to use it, but certain part of the app is not working, that we constitute as that we call as an incident. Generally, incidents can be caused by, or most often it is caused by our tech stack, but it can be also unplanned due to legal reason or some kind of natural calamity. Incidents are generally denoted with a level and scope. A level represent the severity of the incident, while the scope represent how far the geographic reach of individual incident. Incidents generally are discovered by our alerting mechanism, but it is not always the truth. Sometimes, in case of planned incident, uh, operations folks, com ops, or our green hub folks can also file an incident. We call that as a reporting. Once the incident is filed, it is generally reached out to individual engineers or the concerned parties, and everybody is in the loop and get frequent update around what is happening. Once that happens, generally all the on-call folks will get into motion and will try to fix it as soon as possible. Soon after the incident is mitigated, most of the time during that course, we know the root causes, but oftentimes we do not know. We mitigate it first, and then we circle back and do the root cause analysis. It is also the time we do impact analysis. What is the end user impact, and so forth. Uh, After this, generally every group or every team or individual org at different level of the organization, we go through this incident at a periodic basis. It can be weekly or a monthly basis cadence, depending upon how critical and at which level of the organization this is happening. And we try to understand a lot of part things like its annotation or its attributions are correct. We call this process as review and curation. After all of these things happen, we generally have action items, both tactical and strategic, and we try our best to accommodate those learnings in our strategic planning, either process or kind of people and cultural aspects. So these are the different personas depending upon what incident is happening and what all folks are involved and which stage of the incident is. There are different folks using this incident data to understand, decipher, and decide their course of actions. Okay, so now that we have some idea around what constitutes an incident at Uber and how it is managed or handled at Uber throughout the company, let me start with the basic properties of individual incidents. As I was mentioning, all of these data that I'm sharing are or learning that I'm sharing are primarily based on the technology platform related major incidents, which is several thousands in last few years. This set of incidents, all of them carries three distinct properties with them. Something to call out is that this categorization, the primary purpose of this categorization for us to learn from this incident so that all the learnings and the lessons can be easily integrated back to the system as a feedback cycle, right? So it can be categorized in several different ways, and it might be all might be correct depending upon your organization structure and your mechanics. Okay, so among the three properties that every individual incident carries, the first one is the the domain of the incident. Think of this domain as major web operations domain, things like change management, all sorts of code deploy and configuration deploy, things like capacity management, where you think of capacity in terms of CPU cores, how much cores are allocated or throughputs. The third bigger domain is internal platform. We run as a very similar to cloud native environment where bulk of our services are containerized, including storage systems, but also service mesh kind of things. So all of these are internal platform, and each of them are also going through change management or evolution of their own, and we get incidents from those also. Though they constitute a smaller percentage of this, it is still a significant. And there's a bunch of other things that I have kept that are scattered across different groups. Things like external incident, things like ISP related stuff. We have a lot of payment and third party restaurant and other integrations, and we are prone to their incidents also. We manage them on our side, but they constitute a smaller percentage of this. Just to give some idea, change management related incidents itself are 65 to 85%, depending upon which time of the year is. While capacity management constitutes anywhere between 15 to 25% of our incident. Again, the seasonality varies, but that is the second biggest domain. The third internal platform is around 2 to 5, and the rest is all other types of incident. Other than the domain, the second property that is consistent with all of this incident is that we use one of the golden signal. Think of golden signals as like either throughput or utilization or latency to denote this incident, to characterize those incidents. Also to quantify how much was the impact. If you do want to compare two incidents and how bad, which one was had a greater impact, things like that. And then last, third, and probably most critical property in terms of automated detection of these things are there are graph or time series basic property that are preserved or that are consistent across these incidents that are visible through these golden signals. Things like transient, time series disruptions, interruptions, waveform. I'll give some examples of each of these. So next, we'll jump into individual categories, and each of those categories I will talk and I will present a few incident data in terms of graphs. And though the slides decks and their titles are only providing the group or the categories or the domains, the graphs indicates what golden signal we are using, and the graph during the outage shows the time series property. The change induced incident itself has 4 broad categories. The big one is code deployment or code change, but other than code deployment, we also have configuration change. Configuration changes can be further, be in 2 types of either statically checked like file-based configurations that you check in code or is somewhere, and then or maybe something like Puppet or Chef is dropping it. Can also be dynamic configuration, things like hot properties stored in etcd on Jupyter kind of things. We have our internal systems that does that, but both are changes in both or change introduced by both type of configuration system can also cause incident. The third type of change is a mix of both, which is kind of a dark launch where you have deployed the code and you have gated it by configuration, and later you flip the configuration and the code path is executed, and that then we realize that certain type of change in behavior or incident. A DB schema is another one. There's a whole variety of other type of change, but these 4 roughly constitute almost 80 to 90% of the change management in this incident. In this slide, you can see there's one of the service that had a particular property, a particular code path that was dark launched. And when the property was, or the configuration was enabled, we saw a sudden loss it started returning error. It was rolled out data center to data center, and that's how we first lost half the throughput and then other. Something to note here, the incident itself is denoted with or represented with throughput, and the graph property that we are seeing here is called interruptions. Things like incremental deployment, things like auto rollback, are very relevant for detecting and mitigating this. So consider this, that as if you are doing, if you have to do only one thing for your reliability, probably roll back, and change management or code deployment management is the single most important thing from reliability perspective. The second category, capacity-induced incident, can also happen from a myriad of causes, but there are 3 or 4 big type of capacity changes. One can be a naturally increasing capacity that you have not considered, that we have not considered under, we have not planned it, and we found it by surprise. Can be due to performance change that was introduced by code change or something. There can be also product change. For example, there can be events, and there can be certain type of promotion that leading to sudden surge in traffic, or there can be consumer traffic. Here consumer means another microservice. Our stack is composed of thousands of microservices, and individual microservices call each other, and sometime one of the consumer can change the call pattern, and that can causes certain suddenly a higher requirement of capacity. In this case, you can see I am again using throughput to describe a increasing trend of capacity requirement for a particular service. The last few time slots in the graph represent the downfall by COVID. But other than that, this service was constantly increasing more, having more and more traffic, and we had to keep up with its capacity. This is another example of capacity-induced outage, but here it is a little bit more nuanced. There was a change management that happened where an underlying network library was changed, and that had connection handling issues. It was not closing connection properly, and that lead to file descriptor outage. The graph that you see here is a typical jigsaw graph. And this can be, generally this signal is supposed to be stationary. So when it changes like this, we can confidently detect this is an outage, or this is some kind of bad behavior that was introduced inside the code. The third bigger category of incidents are from our own platforms. Though I'm seeing a bigger because it is a few dozen among the thousands, but in terms of percentage, it is only 2 to 3% or 5% at best when we are pushing in a lot of platform changes. And again, they are broadly categorized in networking, storage, or compute. And there are a lot of smaller category things like our own workflow management and fast kind of service, streaming services, those kind of things. A common issue we have seen is that in this domain is network load balancing issues. Here in this graph, I am denoting individual service, one service, and it has multiple instances of that particular service inside our tech stack. An individual container of that service is receiving different amounts of traffic, leading to different load and different latency profile for each of those. We got it detected, and then a change was rolled out, and you can see there are 2 distinct patterns indicating 2 set of cluster into the data center. But within the clusters, the traffic was balanced. Something to remember, this is what, again, I'm using throughput here to denote per instance throughput to denote the condition. During the outage, there are different type of golden signal and graph that we can use to quantify or categorize them. An example of similar platform-induced outage is that in compute, we had seen sometime noisy neighbors which can hog resource. Either can be CPU or disk IO or network, depending upon how you are using container, what kind of things are constraints. Not always we will throttle everything, including the CPU memory. Sometimes network namespaces are not being used. So when those kind of neighbors are there and the enforcement mechanisms are not as stringent, they can impact the behavior. In this case, one of the containers inside a host from a different service was acting, taking up a lot more resources, leading to some aberrations or resource hogging for all other containers. This is the experience or the latency profile observed from another container from the same host, and you can see an oscillation. So this is the oscillation property. In the references section, I have shared a link that enlists the individual graph type that are very similar to our experiences. So you can get a catalog of that. So this was another example of a platform-induced incident. But these 4 categories, platform capacity and change management, constitute bulk of the incident. Our key learning was that we can group these incidents in different functional groups And doing so gives us the best uh, possibility to incorporate back these learnings to individual group and the systems, because deployment is a dedicated system and deployment practices are well known practices within our domain. For example, we know that we have to do incremental deployment. We have a understanding of staging environment and feature gated deployment and stuff like this. So this is works for us. But if it is a different kind of setup where you are doing, say, embedded system or some other kind of off the shelf product builders, it might be a little bit different kind of categorization. And but categorizing it in terms of your organization structure or your tooling structure will help you give you the best chance to streamlining the feedback. So that's enough of the categorization and the taxonomy itself. Again, to recap, consider every incident as a tuple of three things: a domain, a golden signal that is used to characterize it, and the graph property, which is the time series topology or format of that behavior of particular golden signal during the time of outage. With that said, I think I would like to take the last few minutes to talk about a couple of our key learnings from this. When we excuse me. Yes. So with that said, I want to share a couple of key learnings. The first and foremost thing was restorative justice process. This is a superset of learning or a field that is very related to resiliency engineering or blameless postmortem, right? So what this field of study does is that it emphasizes on the well-being or the empathetic approach of treating incident, and particularly folks involved in the incident. These practices and these studies have been primarily done in the healthcare sector or fire, FEMA kind of setup. And what we have learned is that legitimizing those culture, right, and legitimizing those acts and those folks who are involved in this process, those are the institutional, evidences, and they are the ones who know most what happened. So building a process where they are encouraged to add these data, capture it, and they feel empowered is of utmost critical. In 2017, bulk of our incidents was not annotated, and we could not get all the data reliable because the process was stringent and there was a bunch of other hindrance, right? So we had to resolve those things individually and make it much more lightweight. And we also have to accept and legitimize ambiguity sometime when you are working with a complex system in a given short span of time. Not everything could be deduced in a strict time, and so nobody can be held accountable for enforcing that kind of things. So those things was relaxed, and as a result, by 2018 we got a lot more data, and that got feedback into the system, and overall our things was improved a lot more than where it was in 2017. So empathy has been a critical and probably a central element across the board from this process. Without that kind of cultural shift, it is not possible to even get to this kind of data. The second part is the resiliency engineering part of it, which is basically reliability, but with a very good understanding of sustainability. Think of that. We talk about burnout. We talk about a lot of incident management technique. At the same time, in parallel, we talk about project management, things like XP, Scrum, right? But there are very few resources or very few practices that talks about how we can systematically take those learning from on-call, take those learning from incident management, and add it back into the project management cycle. So our learning was that almost 30% of it is process, pure process, and evangelism, onboarding, right? Shadow on-call kind of rotation, all of this, how you do induct new members. So allocate time for that. So if you are an individual contributor, bring those things in your weekly planning or sprint planning. If you're a leader, or if you're a manager type of person, incorporate those in your strategic planning, in your OKRs or your quarterly planning. More importantly, celebrate those wins, and those are critical part of your product portfolio. So treating those things as critical as product feature and making them as a concrete part of your software development lifecycle actually legitimize and incentivize the folks. Not only that, this also opens up and streamlines the folks that are involved, their career and their maturity within this domain. Like they can see how this thing lines up or it adds up to this. It should not be treated as a toy. This was all I wanted to share. Thank you so much for tuning in. I have not been able to cover everything that I could because of time constraints. I have added a bunch of references. Definitely, Resiliency Engineering, the Resiliency Roundup newsletter is the one I would strongly recommend. Other than that, Anti-Fragility and Restorative Justice Process. These are some of the cultural things highly recommended for anyone wants to know more. In terms of data mining, STL decomposition, things like change point detection. I have linked a white paper from a power distribution company, APC, if you have used the UPS. The reason I add it is that they are learning from the aberrations in power signal or even actually electrical grid are very similar to what is our learning. We could not share exact data from our system, but this is an open source data. So you can look at the graph properties and get a good understanding about the data mining aspect of it. Thank you for your time.
Thank you so much for your talk. It's so cool to get to hear how much Uber has grown in this incident space.
Thank you.
We didn't get a chance to meet when I was at Uber, but I was there in 2016 to 2018. I was an SRE, worked in cloud infrastructure, and then moved on to Uber platform. So it's really amazing to now see how much incidents have grown, and like now seeing the categories, like it was really cool to see that it's like through output, utility, and then those golden signals. Like it really is key to be able to start learning from incidents.
Yes.
So I'm going to go first with one of the questions that we got asked from the public, but then I had one or two questions that I want to throw at you. So the first one that we had come in that folks were asking, what is the first step in getting started in building this resiliency? Is there one thing we should go after? Like, what would that be?
I would first say that set up a process for capturing it and set up some understanding of what is normal. In the beginning, it is kind of a line in the sand. You have to decide where you want to hold the bar. Depending upon whether you have already a high throughput business or you are just starting off, some data might be there and some might not be. You might have to build a tool. So categorizing those and setting up a common understanding. This is what you're going to track, because everybody in the product development lifecycle has to be agreed upon. Once you have that, then you can get into motion.
That is like best advice that we really don't hear out in the industry right now. It's amazing to have folks actually think about what is the data that really does say our systems are normal, and then kind of like normalize it across the entire stack, or at least for those like Seb 1, Seb 2 systems.
Yeah, a common glossary, if I say so. For example, for us, Seb 5 means Seb 5 and 4 mean externally visible high impact incident, and we use level and scope. Level is the impact, and the scope is the geographical distribution. Low means a city, medium means a continent to a region, and high means global. So having it does not need to be like this. Some folks, some organizations represent L0 or L1 as the most severe. But as long as you have a common understanding, that is the starting point.
Do you think that, like, I know you touched upon, you have to take a lot of learning from like what you're doing on call, the incidents that you go through. And I know you mentioned onboarding. So I remember like education, we had chaos engineering being even part of education. Like, do you think that now that learning of like what is the data that every single engineer needs to keep in mind for their job, is that something that y'all have now implemented? Do you think that's the best practice?
Yes, I do. I do think so. But I would also emphasize that tech is a very dynamic place in terms of people, in terms of places, in terms of everything that we use. So we have at multiple steps of our induction program. That means if you join Uber, you go through education program, and reliability and observability are part of an integral part of that. But even other than that, this is a very broad spectrum, tech stack wide understanding of things. Individual team has their induction program. They should. And that involves not only introducing and setting up the initial relationship, but also shadowing on call and going through the runbook. That do I understand? Even to going through the access to all the tools. Do you have it? So all of those are, I think, are very critical.
Yes, I always now say, like, have chaos engineering as being able to train folks to be on call. I know that was one of the things that we were trying when I was there, of like, here's the run book. Do you actually know what to do? Because it's you have to know where that dashboard is, exactly what to execute, how to stay in touch and post communication in your outward facing platform.
Yes.
So one of the questions that I kind of wanted to have is like, how is it that y'all are like taking the learnings from these incidents and like also now doing the capacity planning? Like, I know right now it's like that time before peak season kind of kicks off for y'all.
Yeah, it's actually it's a pretty interesting time from reliability perspective, because we had COVID impact, but at the same time our delivery and other business has grown, and we are on our way to recovery. So a lot of this data, when it boils down to individual service, and it is compounded by product launches, this can be a very significant change for many of the services. So there are a bunch of things other than traditional alerting. We do also automated load testing and traffic shaping. Those things require a lot more deep dive, so probably a separate discussion. But there are automated, semi-automated mechanism other than the baseline, alerting. But I think I also should mention out that we do full region level failovers and zones. Think of like that, and that's I find it very fascinating and crazy at the same time, that we do this kind of game day, which is actually, and we do it at a weekly or bi-weekly basis.
I
And
still, oh,
yeah,
I was about to say, like, I still remember like 2017 Halloween, where it was like those 2 months pre-Halloween that we were just doing complete failover exercises like every single week. And it was like one of my friends was involved every single week. So it was always like someone was busy, but it was that load testing, the traffic, the chaos engineering. Do you know everything? We're going to do this at 8 p.m., 4 a.m. Like,
yep,
I think Sunbury was leading up that project. So it was amazing
yes,
to see
yes,
just like that really big spreadsheet of like, this is everything you gotta do. This is
yeah,
a hip
yeah,
chat
yeah,
channel. Like, this is the backup channel for communication.
yeah. That was back in 2016. And think of this, that now this is a lot of tooling has been built. So it's like a giant continuous integration cycle for us, for all the run book and for the emergency preparedness, and we execute it every week. And life got
That's
a lot better since then.
that's amazing. And actually, that segues me into my next question. The last question before we close out to send folk the rest of the questions to the Q&A channel. The question is there tooling available that helps you automatically categorize metrics during an outage?
Yes and no. We, as a community, we know different in different aspects. What are the different tools? For example, the thing that I mentioned, STL, is very popular in financial domain, even within time series databases and web operations like DevOps, SRE, different folks, AI ops, for example. They have mentioned it, and all of these individual tools. So think of that individual tools has been talked, but what is not true is that you cannot do all of those tools everywhere. So the context is very important, and the domain. And the second part is that there are harder problems. You have to be able to explain what it is. Some of this complex heuristic model or simulations may not be easily understandable if you do not aware of the domain. Point being,
That's
this entire arsenal of ML-based techniques of detection and things, or not even ML, maybe it is some kind of expert system where and it's just an operator coming up with a fancy predicate. But taking this set of available options and applying it into individual relevant domain and signals is the art, I think. And that is the thing we have to do as a community.
Yes, that's such a beautiful ending to that question. It's like we do have to do this as a community, and it's about like sharing those best practices. So thank you so much for your talk. I think you gave so many nice little resources for folks to follow up. I know more questions are currently getting posted, so you get a chance to now answer those questions in your Q&A channel, QA-Ranjib Day. And we would love to thank you for being such a great speaker and contribution to ChaosConf.
Thank you so much.